So we're going to talk about writing linear equations from word problems. There are two ideas we've used in the past that are pretty important here. So first off, we have slope, which is the same thing as our change in y over our change in x, which sometimes we just say rise over run. What we're going to call it, because these are changes, change over change, so miles per hour or money per month. So we're just going to go ahead and say this is actually a rate of change. It's the rate at which we are changing two items, whatever's on our x-axis, whatever's on our y-axis. Then the other idea that we talked a lot about is the y-intercept. And for us, the y-intercept is actually a constant. Since the y-intercept represents what's on the y-axis, our output, it's whatever output we begin with. And you'll see that as we move through these problems. So here we go. John purchases concert tickets for himself and some friends. The first ticket is $35, and each additional ticket is $20. Create a cost equation if John has F friends. Write your equation in standard form. So lots of vocabulary there. Cost equation, standard form, that we're going to go ahead and put into this equation. So let's just go ahead and say this. What is our rate of change? At what rate do we change? Well, we change at a rate of $20 per friend. So $20 per friend. For every friend, I pay $20. I have one friend, I pay $20. I have two friends, I pay $40. So I know that C of F, this cost function, is equal to 20 times F. And then what's our constant? What do we begin with? Even if we have 0 friends, what do we have to pay? Well, we have to pay $35 for this first ticket to get in. This is our constant. That's our y-intercept, but it's our constant. That's what we call it. So plus 35, and that's our cost equation. I have 0 friends, I pay $35. I have 1 friend, I pay 35 plus 20, which is 55. Well, now this wants to know right here in the second portion, what is John's total cost if John has 6 friends? Well, the way that I evaluate that is I say, take all the F's and replace them with 6's. So 20 times 6 plus 35. 20 times 6 is 120. Plus 35 is simply 155. So that's my blank 2, 155. You can see we've used slope, rate of change, and you can see we've used y-intercept, which is a constant, and they appear in the same place, right? Your slope was always next to your variable, and your rate of change, your slope was always next to your variable, and your y-intercept was always at the end. Same idea. This is standard form because the variable comes before the constant. Next example. I've got 20 here, so the first ticket is $20, and each additional is 16. That means that I have 16 for every friend, plus 20 to begin with, and I can just type that in, 16 per friend, plus 20 constant, and then I can evaluate. I take out the F, I plug in 3, and I have 16 times 3 plus 20. 16 times 3 is going to be 48, and then I add 20 to it, which is going to be 68. If you need to do side work for that math, that's fine. I just did this in my head because I wrote the problems. I know what it's going to be. But if you need to do 16 times 3 as side work, and you want to say that's 18, that's 3 plus 1. Okay, 48 plus 20. Well, 48 plus 20. 8 plus 0 is 8. 4 plus 2 is 6. You can do the side work, right? That's totally fine and acceptable. Don't feel bad about that. Next problem. So now John purchases concert tickets for himself and some friends, and the first ticket's $7. And each additional ticket is 3. So we're going to create a cost equation if John has F friends. Well, it's $3 for each additional friend plus the initial 7. See, I'm able to throw this together now. I'm kind of familiar with the question. And then I just, down here, I evaluate wherever f is. I plug in 10, and I have 3 times 10 plus 7. That's 37. So I'll type in my cost equation, 3f plus 7, and I'll type in my total when I have 10 friends, which is 37. And we are on to the next example. Jose is saving up for college. Slightly different worded problem. He currently has $1,546 saved. Each month he saves an additional $687. Create a savings equation if Jose saves for m months. Write your equation in standard form. Well, we can do that. Even though this problem is different, it's still similar enough that this is something that we can compute. So if we want to look at what's our rate of change, well, we're changing 687 every month. That's what we're changing, 687 every month. And then he currently has 1546, so that's our constant. That's what we're starting out with. That is our y-intercept, our constant, 1546. Then we want to know down here, how much does Jose have if he saves for 8 months? Well, we take 687 per month for 8 months plus the 1546. I'll write my equation here, 687 m plus 1546, and then I'll do my computation. 687 times 8 is 5,496. I add 1,546, and I end up with 7,042. So I can type that in my second blank, 7,042. Again, different problem, same concept. Here is our last example for the day. Jose is saving up for college. He currently has $67,864 saved. Each month he saves $452. Create a savings equation if Jose saves for m months. Write your equation in standard form. So we're going to create an equation just like we normally did. And I'm going to say, okay, constant. And then this, of course, is my rate of change. So $452 per month, plus $67,864 that are already saved. And I can type that in, 452 m plus 67,864. And if you want to put in the comma, that's fine. Either way, you're going to get it right in Schoology. I'm not putting in the comma just because I don't want to. And then this second question is slightly different than what we've been seeing. It says, how many months does Jose have to save if he needs $100,000 for college, round up to the nearest whole number? So in the past, it's given us some m that we've been able to plug in for. So like down here, it'd say 10 or something. Now it's giving us an output, and we need to solve for m. Well, it's similar as one-step, two-step, or multi-step equation, where we just say, well, $100,000 is equal to my equation, 452m plus 67,864. And then I can use inverse operations. And I'm also using a calculator to compute these numbers. You don't have to, but you can. I just do it because I can do it faster on a calculator than I can in my head. And that's kind of my rule of thumb for when I use a calculator, is if I can do it faster on a calculator than I can in my head. So I've got 100,000 minus 67,864. And that turns out to be 32,136. And then that's still equal to 452m, and so I'm going to divide by 452, just like we would any other two-step equation. So when I divide by 452, my final answer is 71.09. So I want you to think about this for a second. 71.097. If I say for 71 years, do I have 100,000, or sorry, 71 months. If I say for 71 months, do I have $100,000? No, because I still have to save for 0.097 of a year, or of a month. So in order for me to save $100,000, I need to save at least 72 months. So this asks me to round up to the nearest whole number. I need to save at least 72 months to have $100,000, because at 71 months, I'm not there yet. At 72 months, I'll have more than $100,000, But at 71 months, I don't have it. So I'm going to round up to the nearest whole number, 72 months. Good luck on the homework. If you have questions, feel free to comment in Schoology. You'll notice next to the homework tab, there's also a comment tab. And in those comments, you can ask questions about the homework, or you can ask questions about the videos. And students who respond, so students who are helpful, students who go out of their way to help teach their fellow students through this flipped classroom will be eligible for extra credit in my classroom. I can't say for the other teacher, but in my classroom, you'll be eligible for extra credit. Good luck.